Okay, today I will continue to explain about the reaction of halide ion, okay, with concentrated sulfuric acid. Okay, this is one of the halide tests. Here is the notes of reaction of solid halide with concentrated sulfuric acid that I already made. Alright, okay, before I go further, okay, what is the concentrated sulfuric acid? Okay, this concentrated sulfuric acid is actually an acid, okay, and it is a strong oxidizing agent. And as we know that the halogens are also oxidizing agent. So in explaining about this, okay, I will show the standard reduction potential. Okay, so this is the standard reduction potential of halogen. Okay, according to this standard reduction potential, you know that this fluorine is a stronger oxidizing agent. Okay, and when the more positive is a more stronger oxidizing agent. Okay, so when it's going down the group, okay, how about the oxidizing strength? Okay, so oxidizing strength getting weaker. Okay, oxidizing strength when going down the group getting weaker. Alright, so as we know that the reactant is all the oxidizing agent. Okay, how about its product? Okay, so its product, okay, because of this reactant is a stronger oxidizing agent, okay, like fluorine. So how about the fluoride ion? So fluoride ion is the weaker reducing agent. So all the product will act as a reducing agent. And as we know, when it's going down the group, okay, the reducing strength, okay, reducing strength getting stronger. So what happened here is, okay, so iodide ion, okay, will act as a stronger reducing agent. Alright, because it's halide. So all the halide will act as a reducing agent. Alright, okay, so for all the reactant, okay, fluorine is a stronger oxidizing agent, hence its fluoride ion is a weaker reducing agent. Right, so same goes to iodine. Iodine is a weaker oxidizing agent. So all the reactant will act as oxidizing agent. All the product, which is all the halide ion, will act as a reducing agent. What is the position of sulfuric acid here right now? Here is the sulfuric acid. Alright, so sulfuric acid, okay, which is the reactant, which is a stronger oxidizing agent, okay, then bromine and then iodine. So that's why this sulfuric acid is able to oxidize bromine ion to form bromine. Okay, sulfuric acid is also able to oxidize iodide ion to form iodine. Okay, so from this standard reduction potential, you can see that this chlorine is stronger oxidizing agent than sulfuric acid. Since this reaction is involved of solid halides with concentrated sulfuric acid, so this halide involved of chloride, bromine and iodide. Okay, so we can say that sulfuric acid is an oxidizing agent. Okay, while all the halide ion, okay, halide ions, okay, are reducing agent. Alright. Okay, let's say I have a 3 container of sodium chloride, sodium bromide and sodium iodide. And then I drop it a few drops of concentrated sulfuric acid. Okay, concentrated sulfuric acid into sodium bromide. Okay, also get a few drops of concentrated sulfuric acid into sodium iodide. So from this reaction, actually we will write some observation. Okay, during this reaction, actually they have 2 types of reaction that will be occur. The first one, it will occur the displacement reaction. Okay, the first one. And the second one, okay, the second one is the redox reaction. So they have two types of reaction that will be occur during this reaction. This is my overall mind map, okay, in explaining the reaction of concentrated sulfuric acid to the halide. We start with the first reaction, which is displacement reaction. Okay, now we refer to the first displacement reaction, okay, for the sodium chloride, okay, to the sulfuric acid. Okay, sulfuric acid. Okay, what is the product form? Okay, for the first one, because of sulfuric acid is a diprotic acid, so it will occur the 1 and 2 dissociation process. So it will happen 2 dissociation. Okay, for the first dissociation, so it will form, alright, sodium hydrogen, okay, sulfate, alright, and then HCl gas, which is this one is a white fume gas. Alright, this is the first dissociation reaction, okay, of diprotic acid. Okay, we continue by NaCl, okay, react with sodium hydrogen sulfate, okay, and then it will form sodium disodium sulfate, alright, and plus HCl gas, hydrogen chloride gas. Okay, so this is the double displacement reaction. Alright, so we write the equation here. Okay, when we write the overall equation, so we will get 2 NaCl, right, and then react with sulfuric acid, okay, and then it will form, okay, sodium sulfate, okay, plus 2 mole of hydrogen chloride gas. Alright, so this is the reaction. We take a look for the bromide, okay, which is we use sodium, okay, bromide, okay, and we react it with sulfuric acid. Okay, so it will occur the first dissociation, which is sodium hydrogen, okay, sulfate will form, okay, plus hydrogen bromide gas, also gas. Okay, and then second dissociation, okay, sodium bromide, right, it will react with sodium hydrogen sulfate, okay, to form sodium sulfate, disodium sulfate, alright, plus hydrogen bromide gas. So when we react we will form the overall reaction, okay, for displacement, okay, we will get 2 NaBr, okay, plus sulfuric acid, alright, and then it will form, okay, sodium sulfate, okay, plus 2 mole of hydrogen bromide gas. So this is the second reaction of bromide. Displacement reaction of iodide or sodium iodide. Alright, solid halide. Solid halide, we use sodium iodide. Okay, and then we react it with concentrated sulfuric acid. So the first dissociation, it will form sodium hydrogen sulfate, okay, plus hydrogen iodide gas, okay, hydrogen iodide gas. Okay, and then second dissociation, it will form, okay, sodium iodide will react with sodium hydrogen sulfate, okay, and then it will form, okay, disodium sulfate, okay, plus hydrogen iodide gas, right. And then for the overall reaction, so for the overall reaction, okay, so we will get 2 mole of sodium iodide, okay, react with concentrated sulfuric acid, so it will form, okay, sodium sulfate, okay, plus 2 mole of hydrogen iodide gas. Now we have the displacement reaction, okay, between the 3 types of halide. So the overall reaction of the displacement reaction is we put as a reaction 1. Okay, refer to this diagram. So I have said that the second reaction will be is redox reaction. Alright, so okay, in redox reaction, okay, what happen is, okay, if you can see that the product form here is hydrogen chloride gas, hydrogen bromide gas, and hydrogen iodide gas. Okay, how about the reaction of HCl, okay, with sulfuric acid? Because this is still in a same test tube. Alright. Okay, so how about the reaction of sulfuric acid with hydrogen chloride gas? Okay, and then how about hydrogen bromide gas with the sulfuric acid? Okay, we refer back to our standard reduction potential here. Alright, so since sulfuric acid is a stronger oxidizing agent than bromine and iodine, so sulfuric acid is able to oxidize bromide to bromine and iodide to iodine. So what happened here is, okay, for hydrogen chloride gas, okay, this sulfuric acid is not strong enough to oxidize this chloride ion to form chlorine. So it cannot oxidize. Alright. Now for the second reaction, which is redox reaction, okay, if you see that in this test tube, now it's left sulfuric acid, okay, and hydrogen chloride gas. Okay, okay, and then we have in the second test tube sulfuric acid, okay, with hydrogen bromide gas. Alright, and then the third test tube we have sulfuric acid, okay, and hydrogen iodide gas. So which reaction will occur the redox reaction? And for sure that for this reaction it will be not occur because chlorine is a stronger oxidizing agent compared to sulfuric acid, so it cannot oxidize this chloride, right? So they have no reaction occur. Okay, but for this both, okay, reaction will be occur. Alright, so okay, for this reaction it consists of sulfuric acid, which is this sulfuric acid, okay, will act as oxidizing agent. Okay, while its halide will act as a reducing agent. Alright, meaning that this oxidizing agent will reduce the bromide to form bromine. Alright. Okay, so same goes to iodide. Okay, so this sulfuric acid, okay, what is the process that will be occur is a reduction process. Okay, while for halide, okay, will occur the oxidation process. Alright. Okay, now for redox reaction, okay, we have two compound that evolve. Okay, which is the first one we have sulfuric acid. So we have sulfuric acid here. Alright, so for sulfuric acid, it will occur the reduction process. Okay, this sulfuric acid, okay, will reduce itself, okay, to form three different compound. Okay, the first one, it will form sulfur dioxide. Alright. Okay, the second one, sulfuric acid will reduce, okay, to sulfur itself. And the third one, okay, okay, sulfur will reduce, okay, to hydrogen sulfide compound. Is the oxidation state in sulfuric acid? Alright, so we calculate this S, okay, in sulfuric acid, which is, okay, when we ionize, we will form sulfate ion here. So sulfur plus 4, okay, negative 2 equal to negative 2. So this sulfur we will get negative 2, okay, plus 8. So positive 6 oxidation number. So this sulfuric acid is positive 6. So how about the sulfur dioxide? Okay, so sulfur is a molecule, so we plus to 2, negative 2 equal to 0. So this sulfur is, we get positive 4. Sulfur in SO2 is positive 4, okay. Right, second one is sulfur. Sulfur itself is a 0 oxidation number. Okay, why H2S, hydrogen sulfide? Okay, so we know that sulfur, when we sulfur will add as a S2 minus. So this one is a negative 2. About the oxidation, okay, now is the oxidation is a halide. Okay, halide, HBr and Hi. Alright, so now is for oxidation process. Okay, hydrogen bromide gas, which is bromide ion. Okay, it will oxidize itself to form bromine. Alright, okay, while hydrogen iodide, okay, it will oxidize itself to form iodine. So this is the oxidation changes here is from -1, okay, to 0, and from -1 to 0. So this is the oxidation process. Look at to the redox reaction table. Alright, so okay, the first one, let's define the redox reaction, okay, which is the reduction and oxidation process occur simultaneously. Alright, so okay, from this table, okay, we can see that this is the hydrogen halide and this is the sulfuric acid. Okay, so we will react both. Okay, from this redox reaction, okay, from sulfuric acid, okay, because it's occur the reduction, so it will reduce, okay, to either, okay, 4 sulfur dioxide, okay, or, okay, 2 sulfur itself, okay, or hydrogen sulfide, okay, which is the oxidation number, okay, of each is +6 for sulfuric acid. Okay, and then it will reduce to sulfur dioxide, which is +4. Okay, sulfur 0. Okay, and then hydrogen sulfide is -2. Alright. Okay, and then we refer to the halide. Okay, this is the halide table. So for halide, okay, we involve chloride ion. Okay, we involve bromide ion. Okay, and we involve iodide ion. Alright, so this is the table of the redox reaction. The first thing is when hydrogen halide react with sulfuric acid, it will form water molecule. Alright, okay, so for the first reaction, when HCl react with sulfuric acid, so they have no reaction occur. Right, so they have no reaction occur. Alright. Okay, for second one, when bromide ion is react with sulfuric acid here, okay, what will happen is, alright, refer to our standard reduction potential here, okay, which is sulfuric acid is able to oxidize bromide to form bromine. Alright, so that what happen is bromide will oxidize to form bromine. Okay, bromine molecule here. Okay, and then how about sulfuric acid? So this sulfuric acid is able to reduce to sulfur dioxide. Okay, and then it release also water. It form also water. So what is the oxidation number changes here? Okay, so for oxidation, okay, so we can see that bromide ion, okay, which is -1, is being oxidized to 0. Okay, while for reduction, okay, which is +6 of sulfuric acid are being reduced to sulfur dioxide, which is +4. Now we take a look the reaction of iodide, okay, to sulfuric acid. Okay, what would happen here? Okay, so refer to standard reduction potential again. So sulfuric acid, okay, is able to oxidize iodide to form iodine, and At the same time, iodide ion is a stronger reducing agent. Okay, hence is able to reduce the sulfuric acid to the O compound, okay, of sulfuric acid. Alright, which because of the stronger reducing agent of iodide, so it's able to reduce the sulfuric acid to all the compound here. Okay. Okay. So for the first reaction of sulfuric acid with iodide, okay, it's the first one, it will form iodine. Alright, for sure. Okay, and the first possible that it will form is sulfur dioxide. Okay, and then water. Alright, so this is the first redox reaction that would be occur when iodide react with sulfuric acid. Okay, so how about the oxidation number here? So for oxidation is stay same. Okay, -1. Okay, to 0. Okay, how about the reduction here? Okay, +6 of sulfuric acid. Okay, we reduce to +4 of sulfur dioxide. Okay, the second reaction of iodide, right, to the sulfuric acid here that we can observe here is, right, the first one, okay, the oxidation, for sure it will release iodine, okay, iodine gas, okay, and then the second possibility that it will reduce, okay, from sulfuric acid is sulfur itself, and of course water. Alright, okay, and then what is the oxidation changes, oxidation number changes here for oxidation? Okay, same. Okay, for reduction, okay, it will reduce from +6, okay, to sulfur, which is 0. Okay, okay, the third, okay, reaction between iodide to sulfuric acid. Okay, the third possibility is, okay, first one, for sure it will release iodine, okay, iodine vapor. Alright, okay, and then the third reducing that will be occur is sulfuric acid will reduce to hydrogen sulfide, okay, and water for sure. Okay, what is the oxidation changes here? Okay, -1 to 0, and for reduction, okay, it will reduce +6 of sulfuric acid, okay, to negative 2 oxidation number. I want to show the line number of reduction of sulfuric acid. Okay, for the first one is from +6 to +4. So we can see that this, okay, +6 being reduced, okay, to +4 here. Alright, so around 2 electron, okay, would be reduced. The second reduction is sulfuric acid reduced to sulfur, so which is +6 reduced to 0. So here is the +6, so it reduced to 0 here. Okay, so it reduced to 0 here. Alright, so if you can see that it have 1, 2, 3, 4, 5, 6. So it has 6 electron to be reduced, okay, to be released. Alright, okay, the third reduction is sulfuric acid, okay, +6 be reduced to H2S, which is -2. So from here, so okay, it be reduced to -2 here. So if you can see that here is the 8 electron to be reduced. To our redox table, so this reduction is only 2 electron being released. Okay, 2 electron. Okay, so for iodine here, you can see that the +4 reduced to +2 is around 2 electron. Okay, the second one is 6 electron, and the last one is 8 electron. So from these three reaction, alright, in order to write the overall reaction, right, we must choose the most electron, which is these electrons are reduced completely. So the third reaction of iodine to sulfuric acid, okay, will be chosen as a second reduction in order to write the overall reaction. Now let me show you how to write down the redox reaction. Okay, for this reaction, okay, for the first one for bromine, okay, now we use bromine ion, so we take that as a HBr, right? Okay, and then we react it with sulfuric acid. Okay, so it will form bromine, okay, and then sulfur dioxide, alright, okay, and then water. Okay, this is the reaction, okay, redox reaction of bromide with sulfuric acid, and then we balance it. Okay, now if you can see that the electron being reduced, okay, is a 2 electron, so now is directly we put 2 mole of hydrogen bromide here. Okay, and then just balance all the equation here. Okay, so water consists of 4, so we have 2 here. So we already balanced the equation of hydrogen bromide. Now redox reaction of hydrogen chloride to sulfuric acid. Okay, we do the first one first. Okay, and then for iodide, we write down as a hydrogen iodide. Okay, and then it react with sulfuric acid. Okay, so then the product form is, okay, the first one iodine here. Okay, and then followed by sulfur dioxide. Okay, and then followed by water. Okay, and then same in balance the equation, we see the how many electron is being reduced, 2 electrons, so 2 mole of hydrogen iodide being removed. Okay, and then just balance the equation here, so we get 2 mole of water also. Okay, so we already balanced the first equation of iodide to sulfuric acid. Okay, now the next reaction, okay, of iodide to sulfuric acid, so we write down as a hydrogen iodide. Okay, we react with sulfuric acid. Okay, and then okay, what is the product here? Iodine. Okay, and then we have sulfur itself. Okay, and then we have water. Okay, now we balance the equation here. Okay, refer to the electron. Okay, so here is the electron being reduced is 6 electron, so we put 6 mole of hydrogen iodide. Okay, react with sulfuric acid, and then we just balance the equation, which is iodine have a 6. Okay, so 3 iodine. Okay, and then water it have, okay, so we just put 4 here. So we already balanced the second reaction of hydrogen iodide with sulfuric acid. Okay, for the final one for redox reaction is iodide. Okay, iodide. Okay, so I write down as a hydrogen iodide. Okay, react with sulfuric acid. Okay, and then what is the product form here is iodine. Alright. Okay, and then followed by hydrogen sulfide. Okay, H2S. Okay, and water here. Okay, and then okay, how to balance the equation? We see the electron, total electron that being reduced is 8 electrons. So we just put down the 8 hydrogen iodide here. Okay, and then just balance, okay, which is 8 iodine, so we have 4 here. Okay, 8 iodide, so we have 4 iodine. Okay, and then it's already balanced. Okay, and left for water. Water is have 4 here. Okay, so we already balanced all the redox reaction. So this is the redox equation. Okay, let's rewrite the overall reaction. Alright. Okay, so this table is belong to chloride. Okay, this bromide, and this one is for iodide. Alright, so for the reaction between chloride with concentrated sulfuric acid, so the overall reaction is this one lah, right? Because its occur is until this only, right? Which is we release hydrogen chloride gas, okay, and sodium sulfate. So we will write here lah. Okay, now we write here. Okay, which is, okay, for the overall reaction is we have, okay, 2NaCl, okay, which react okay, to sulfuric acid, okay, to form sodium sulfate, okay, plus 2 mole of HCl gas. So this is the overall reaction of chloride with concentrated sulfuric acid. Okay, for reaction of bromide to the sulfuric acid, so it have displacement reaction and also redox reaction, which is this bromide form bromine, and this sulfuric acid is form sulfur dioxide and water. Okay, so now we can write the equation here. Right, so the overall reaction, okay, of bromide here we can write for the first, okay, the first reaction is we take from the displacement reaction, okay, which is 2 mole of NaBr, 2 mole of NaBr, okay, react to the sulfuric acid, okay, so it will form sodium sulfate, okay, plus 2 mole of hydrogen bromide gas. So this is the displacement reaction, okay, and then for redox reaction, okay, for redox reaction, okay, we take that, so for bromine, okay, react with, so bromine is we can put HBr, so this HBr, alright, okay, so this HBr, okay, react with sulfuric acid, okay, react with sulfuric acid, okay, to form, okay, so it will form bromine molecule, it will form sulfur dioxide and water. So it will form bromine molecule, okay, and then it will form sulfur dioxide and it will form water. So this is the second reaction, okay, of bromide to concentrated sulfuric acid, okay, and then we balance the equation. Alright, since the electron is being reduced is 2 electron, so we can write the equation here, which is 2 mole of HBr reacted here. Okay, so you can balance all the equation involved, okay, which is it will form 2 mole of water here, so it's already balanced. Right, so now it's just complete the reaction to form overall reaction. So Br we can cancel out here, right, and then we can write down the overall reaction below. Okay, so we will get 2 mole of NaBr, okay, 2 mole of NaBr, okay, react to 2 mole of sulfuric acid, okay, and then the product form is sodium sulfate, okay, plus bromine, okay, plus SO2 and plus 2 mole of water. So this is the overall reaction occur for bromide to concentrated sulfuric acid. Now let's write the overall reaction, okay, of iodide to concentrated sulfuric acid. Right, for the first one is displacement reaction, then fill up in the table below for displacement reaction here, then we will put, okay, 2 NaI, okay, 2 sulfuric acid, okay, to form sodium sulfate, okay, with 2 mole of hydrogen iodide gas, okay, and then for redox reaction, as I tell you earlier, okay, so we must choose the maximum electron that will be reduced. We choose the product of hydrogen sulfide. Okay, so let's write the equation for the second equation here, which is redox reaction here. So we put Hi, so Hi, okay, react with sulfuric acid, okay, sulfuric acid, okay, the product form is iodine here, okay, and then we have hydrogen sulfide, okay, and then we have water. Alright, okay, then we balance first the chemical equation in redox reaction below, okay, which is, okay, since we have 8 electron here, so 8 mole of hydrogen iodide here. Okay, and then complete the reaction, which is 8 iodide. So we have 4 here. Okay, 4. Okay, and then water. Okay, so we have 4 here. Okay, 4 molecule of water. Alright. Okay, then we can write down the fully equation here, which is hydrogen iodide, okay, mass times by 4. Okay, 4 times 2 get 8 lah. So we can cancel out the 8 mole of hydrogen iodide. Okay, so this one is 4 mole. So this one is this one is 8 sodium iodide. Okay, this one is 4 mole. This one is 4 mole of sodium sulfate. So we can write down the overall reaction here. So 8, we have 8 NaI. Okay, 8 NaI here. Okay. Okay, and then we react with 4 mole of sulfuric acid plus 1 mole of sulfuric acid. So we got 5 sulfuric acid here. Okay, 2 form. Okay, 2 mole of sodium sulfate. Okay, 4 mole of sodium sulfate. Okay, and then we plus 4 mole of iodine. Okay, we plus 2 H2S, and we plus 4 mole of H2O. So this is the overall reaction, okay, of iodide to the sulfuric acid. Now let's rewrite the observation for the reaction here. Okay, for the reaction of sodium chloride, okay, with sulfuric acid. So now we can see that it produces colorless gas, okay, which is HCl, hydrogen chloride gas, which is colorless gas. Alright. Okay, and then for reaction of sodium bromide and sulfuric acid, okay, from displacement reaction, okay, we can see that it releases hydrogen bromide gas. It's also the colorless gas. So we have HBr here. Alright. Okay, which is a colorless gas. Okay, and then we also have, okay, bromine here. Okay, so this bromine is a reddish brown vapor. Okay, and then we have sulfur dioxide gas. Okay, which is sulfur dioxide is a colorless gas. So this is the observation. You must write down the observation. Okay, which is white fume HCl for chlorine. Okay, and then for bromide ion with concentrated sulfuric acid HBr. Okay, white fumes. Okay, bromine, which is reddish brown vapor, and sulfur dioxide is a colorless gas. Okay, and then observation for reaction of iodide to concentrated sulfuric acid. So the first one is it have a hydrogen iodide gas. So Hi gas, hydrogen iodide gas. Okay, and then we have, okay, iodine. Okay, we have iodine here. Okay, which is, okay, purple iodine vapor. Okay, and then we also have H2S. Okay, we also have H2S, hydrogen sulfide, which is this hydrogen sulfide is smell of proton 8. Okay, 8. Okay, and then it also produce sulfur dioxide. Don't forget, so the positive for oxidation state of sulfur, which is SO2. So also must be written here. Okay, which is colorless gas. So this is the observation that can we write here.